This lecture is on voltage. Hopefully, by the end of this lecture, you won't be like Maya Angelou. She says talent is like electricity. We don't understand electricity. We use it. Hopefully, by the end of this module, this unit, you will understand electricity and not just use it. So voltage is, remember we've talked about voltage, it was the amount of energy per charge that we talked about in electrostatics. The goal of this presentation is for you to understand the source and purpose of voltage and to understand the safety guidelines concerning voltage and current. So the water analogy, we said voltage is the pump that pushes the electrons through the wire. Electrons don't really move through the wire, but that's the same basic idea. You're moving some sort of energy, some sort of charge through the wire, and the voltage is what provides that push. Now we've reviewed before. We said that voltage is the electric potential. Okay, we said electric potential, voltage, electromotive force, potential difference. All of those are names for voltage, and that equals the energy divided by the charge. So this is review. We've talked about this already. Charges. Batteries have a positive end and a negative end. So you see a positive end right here, you see a negative end right there. Voltage is the potential difference between these 2 points. So this could be like 10 and this could be 1, but the potential difference or the voltage between those would be 9 because there's 9 difference between them. So the battery is labeled, this is a 9-volt battery. It's a 9-volt battery because the potential difference between these 2 points is 9. So just so you know, this negative end of the battery is generally defined as 0. And then you see this positive end is whatever the difference between them is. A voltage source doesn't have to be positive and negative, it just generally is expressed as 9 and 0. A battery. Most batteries are chemical batteries. They use 2 different electrolyte solutions. You should have learned about this in chemistry. We also talked about it a little bit earlier. But basically, one of these things has positive ions called cations. The other one has negative ions called anions. And what they do is they're connected by a salt bridge, and they're also connected by a wire, which allows ions to move from one to the other and become more balanced. And in doing so, you can actually use those electrons as they go through to do things like light bulbs. So the major sources of voltage that we have batteries, which we've already talked about. We have wall outlets. We also have the dryer outlet, which is a little bit different. We have even holding your hands on a Van de Graaff generator or rubbing your balloon on your head, all create voltage because you have objects that are charged, and those charged objects have energy. So because of that, they have voltage. Now, some sources of voltage are obviously going to be more important than others. It is very, very important that you know, memorize, commit to memory, that an American outlet is supposed to be 120 volts at 60 hertz. Now, generally, they tend to be closer to 110, but they are defined as 120 volts at 60 hertz. The European outlet is defined as 240 volts at 50 hertz. You have to know these. Now, the reason for the difference is American cities actually electrified earlier than European ones, and so at the time of electrification, the standard light bulb uses 120 volts. In Europe, by the time electrification occurred, a newer, more efficient light bulb was made, and it actually needed to operate at 240 volts. Americans do have 240 volt outlets. We do have them usually for your air conditioner, your heater, and your dryer, and they look a little bit different. So they don't look like this standard outlet. It looks more round, and a regular plug wouldn't plug into there for safety reasons. Now you do need to know the common batteries. Generally, a car battery is between 12 and 24 volts, and because of that, I can't actually say, hey, this is a battery, what's the voltage, unless it, of course, says it right here, that it's 12 volts. You have a 9-volt battery. You are expected to know that a square battery that looks like this is a 9-volt battery, and you are expected to know that a cylindrical battery, so a AA, AAA, C battery, D battery, provides 1.5 volts each. You are expected to know that voltage is additive. So whenever you take multiple batteries and put them in a combination like this, the multiple batteries actually add their voltage. So if you have 3 AA batteries, that actually provides 4.5 volts to the device. As long as they are wired so that you have the negative, positive, negative, positive, negative, positive. As long as you have that, in other words, they're in line, they don't oppose each other, the voltage is additive. Now generally we measure voltage with something called a voltmeter. The voltmeter has to be wired in parallel. You now know what parallel is. in order to give a proper reading. Now, if you do not wire it in parallel, if you wire it in series, it will give you a reading, but it won't be the correct reading because a voltmeter has a very, very high resistance. Okay, the high resistance is meant to so that no current really goes through it, but at the same time you can get a reading for voltage. Um, Everybody should know how to operate a voltmeter. In fact, you should own one when you move out on your own. Whenever you're doing electrical work, it is very, very important that you test an electrical outlet before you actually begin work so that you don't get shocked. Other things that we can do to prevent shock is we can adhere to some specific safety rules. Now, it is very, very important that you realize that voltage in and of itself is not dangerous. Now, that is not an excuse to go say, hey, danger, high voltage, let me go grab that power line. Do not do that. It doesn't work. Voltage is related to current, and current is very, very, very dangerous. So generally, high voltage means high current. It doesn't have to, but generally it does. So current is very dangerous, and we'll talk about current in the next unit, but a 0.4 amp current across your chest can stop your heart or start your heart. That's what an AED device does. So voltage in and of itself is not dangerous, but you still need to adhere to the warnings because voltage generally turns into current. So you have electrical safety. So some things to do whenever you're working with electricity to help keep yourself safe is number one, always leave the voltage source off when manipulating the current. So go turn the circuit breaker off, remove the battery, unplug the device, whatever you need to do. That removes the voltage source. Number two, you can wear gloves with high resistance. So these right here are very, very high resistant gloves. They're a very thick form of vulcanized rubber that does not transmit electricity very, very well. Number three, if you are sweating, you need to remove the sweat because your dry skin actually has a great deal of resistance. But whenever you start to sweat, that mixed with the salt in your body actually provides a very, very good conductor. And the fourth one is if you are working with high voltage and high current, it is imperative that you put one hand in your pocket and you only work with one hand. In doing so, you actually provide the electricity a better place to go. The electricity will go down your leg and into your foot and then the ground, as opposed to going across your chest into your other hand, which would, whenever it goes across your chest, that's when you start to have problems with your heart. Now, hopefully, by the end of this lecture, you understand the source and purpose of voltage. You should be able to name the major voltage sources and give their voltage. You should be able to understand the safety and guidelines concerning voltage and current for any given situation.